Okay, good morning. So if you remember, I wrote this example on the board, but we didn't have time. To finalize it. So I would recommend you to start thinking about that if you haven't already done that for 5 minutes, and then we start continuing the lesson. So we have an arithmetic progression, AP for arithmetic progression. We know that the sum of the first 5 terms is 55, the sum of the last 5 terms is 215, and we also know that the sum of all the terms is 351. We are supposed to find the first term, if I call it t sub 1, and the common difference d, yes? We are supposed to find these two. And then, of course, if you want, I can write the formulas here for you. So the formulas that we had so far, let me clean this. We have only 2 formulas for the arithmetic progression. The formula that gives you the nth term, which is t1 plus n minus 1d, and a formula that gives you the sum of the first n terms. So we discovered 2 equivalent formulas. One was in this form, but if you use this one here for Tn, you can write it equivalently in this form. So there are only 2 formulas in arithmetic progression that we want to use. But of course, you need to understand. So I'm just giving you an example because I want you to understand that sometimes just using the formulas are not enough. Okay, so be careful. S sub n means the sum of the first n terms, starting from the first term up to the nth term. Yes. So these are the formulas that we had, and then we are supposed to solve this problem. In this problem, the first term is wanted. The common difference is also wanted. Okay? So I give you 5 minutes to think about it, and then we can solve the problem. Okay, any progress? Okay, so I'll give you a little bit more. Okay, so let us see how it goes. In principle, how many pieces of information you have here, how many pieces of information you see in the problem? This is the way that it is always useful to think. So how many pieces of information is provided for you in this problem? 3, yes? But how many unknowns do you have? How many?
2.
No. 2 of them is demanded, but there is also one hidden one. What is that? The number of terms, yes? So it is 3 unknowns in 3 equations, that's it. So I don't know, you shouldn't struggle with that, yes? This is the way that you have to think. There are 3 pieces of information, 2 of them and 3 unknowns. One of them is the first term, the second one is the common difference, and of course we don't know how many terms are there, yes? So it means that in principle we have 3 equations and 3 unknowns, and then this is a simple problem. You need to set up 3 equations with 3 unknowns and solve it, yes? Might be there is a better way, or I don't know, shortcut to this, but in principle this is possible to do that. So we don't know how many terms are involved. So what we do, we say that, okay, we have a T1, T2, let me write some of them, T3, T4, T5, and this will continue until I reach to the last term, which I don't know which one is the last term. But then the previous one is definitely this, the previous one is this, and the previous one is this, 1, 2, 3, 4, and of course the previous one is this. And then we have something in the middle, yes? So we know that the sum of these numbers is equal to 55, and we know that the sum of these numbers is equal to 215, and then we also know that the sum of all of them is what? 351. Okay, so let me just do it very in a standard way. So if you want to do it in a standard way, what do you know? So you know that the sum of the first 5 terms is 55, so I can write S5 is 55, yes? This I can write. But instead of S5, I can use this formula. So it becomes how much? It becomes 5 instead of n, and T1 I don't know, so this becomes 2T1. But here n is 5 for that formula, of course, yes? It's a little bit tricky. Do you understand what I mean? Here n and this n are different here. So here is the formula for any Sn. I am using it for 5. So S5 is this one, and then I will have 4D, and then divided by 2 is supposed to be 55. If I factor a 2 out, this 2 that I factor out between these two terms will cancel this one, and this 5 I can simplify it with that 51. So if I get, this becomes T1 plus 2D is equal to 11. Am I right? That is one equation. And the other equation is, I want to use this one. But how can I use this piece of information? Because that Sn is the sum of the n terms, but from the first term to the nth term. But here I am starting from Tn minus 4 to Tn. Can I somehow use again that formula Sn? Because you see that if the whole sequence is an arithmetic progression, each part of it is also an arithmetic progression, yes? But the point is that this arithmetic progression starts with T1. If I consider this arithmetic progression, it starts with T2, and etc. So the first terms are different. So you can imagine that this is also an arithmetic progression with 5 terms, but it starts from this term. So this would be the first term in that case. This is one way of doing that. Or, I don't know, you need to find another relation between T1 and D using this piece of information. So let us skip this way of doing it. I know that the sum of them is supposed to be 215. So what can I write? I can write Tn minus 4 plus Tn minus 3 plus Tn minus 2 plus Tn minus 1 plus Tn is 250. Yes? But then I can use this formula for this, and that. Yes? Because my goal is to find another relation between T1, D, and N. I have 3 unknowns and 3 equations. Yes? So this is one of my equations. So instead of Tn minus 4, what can I write? I can write T1, yes, plus the number here minus 1 times D. But the number here is n minus 4. If I subtract 1 from it, it becomes n minus 5 times D, yes? And the next one becomes what? T1 plus n minus 4 D. The next one becomes T1 plus n minus 3D. The next one becomes T1 plus n minus 2D. And finally T1 plus n minus 1D. Yes, is that understandable? So I'm just replacing the formulas for these 5 terms. This is supposed to be 215. That is also a good way. Why? Because the unknowns that appear are the 3 unknowns, T1, D, and N. And I told you that this is good. Yes? It might be algebraically hard, but in principle it should be doable. Because I am writing equations with the unknowns that I need to know. So 1, 2, 3, 4, 5 T1s. Okay, and then if you don't mind, let me factor a D out from these terms, and then let us do it in our head. So n, and it becomes 5n. And then I have minus 5, minus 4 is minus 9, minus 12, minus 14, minus 15 is equal to 250. Yes? Of course, I can simplify this. I can divide everything by 5. So then what happens? I will have another equation. So this becomes T1 plus, if I divide this by 5, it becomes n minus 3d equals to, if I divide this by 5, 43. Yes. So that is also a good step. Why? Because if I ask you what are the unknowns involved in this problem, in this equation, T1, N, and D. And we were able to predict that before we started. So I have 2 equations, 3 unknowns yet. In principle, I need one more piece of information, yes? And that piece of information is provided here. Okay? So it means that the sum of all the terms is 315. So I can use this formula here. So I would say that the total number, which I don't know, times T1 plus N minus 1D divided by 2 is equal to 351. Yes? And then what happens if I multiply this by 2 and then I multiply this by here, so this becomes nt1 plus n minus 1d. If I multiply that, it becomes 702. So in principle, how many equations I see on the board? I have 3 equations, but I have exactly 3 unknowns. T1, D, and N. Do you agree with the calculations? Yes? Okay, but then of course it becomes algebraically a little bit hard, because I have to solve these 3 equations. In principle, I should be able to find all 3 of them, but I need only 2 of them, D and T1. Okay, so what I'm supposed to calculate here is a little bit hard if I want to do it here, but this is doable. So it means that I have to write my system of equations here. T1 plus 2D is equal to 11. Another one is T1 plus N minus 3D is equal to 43. And then unfortunately, because this one is not linear in N, it becomes harder. Okay, so I should be able to solve this system of equations in 3 unknowns and 3 equations in 3 unknowns. Okay, do you have any suggestions if I want to solve that? How should I do that? At this level, you should know these things without any problems. Yes, you want to solve this system, so you need to eliminate variables so that you can end up at the end with 1 equation with 1 unknown. Yes, and of course you need to have a little bit of experience. Which one is easier to simplify? I don't know. Which one do you prefer? So for example, let us do one thing. Let us subtract this one from that one, because T1 will be eliminated. So if I multiply this by a minus sign and add it here, negative T1 and T1 will cancel. It becomes minus 2D, and this one, it becomes N minus 5D, yes? So that if I do that, it becomes N minus 5D, and on the right hand side, it becomes how much? 32. Yes? And then I have to calculate N from here, for example. I want to get rid of N. So N minus 5 becomes 32 over D. And then, of course, you see that N is 32 over D plus 5. Okay? So what can I do? I can go to the third equation. I can write 2, but instead of N, I can write this. Yes, instead of T1, I write this one. I want to keep D only. So instead of T1, I would write 11 minus 2D. And then instead of N again, I put this. And then subtract it from 1, it becomes that. And then I have also a D here, and then this becomes 702. So if I ask you in this equation, what is the only unknown that you have, you see that is just D. In principle, you can solve that, yes. So I really recommend you to try to solve this equation and find D. Okay, let us keep it on the board. So what I want to tell you is that at least this way of doing, you should be able to do it, okay? But this is not the efficient way to do that. It's a much simpler way to solve this problem, okay? But in principle, we can solve it using this method. Okay. What can I do now if I want to solve it simpler? So let me clean these because we don't need them. Instead of using formulas, let us use the idea behind the arithmetic progression. Okay, so here I know that T1 is T1. I know that the sum of these 5 terms is 55. Instead of using the formulas which will give rise to these harder equations, let me just do it like this. Instead of T2, what can I write? I can write T1 plus 1D, yes? And instead of T3, I can write T1 plus 2D. And instead of T4, I can write T1 plus 3D. And then this becomes T1 plus 4D. So we know that this is 55. And I will be able to do this in that way. So how? Instead of Tn, let me write Tn. But instead of Tn minus 1, what can I write? I can write Tn minus 1D. Yes? And instead of Tn minus 2, what can I write? I can write Tn minus 2D. And instead of this one, I can write Tn minus 3D. And the other one would be Tn minus 4D. Agree? And this is equal to 215. And then I add them. What motivates me to add them? Because I see that when I add them, this minus 4D here and that 4D here are cancelled. And this minus 3D here and this 3D are cancelled. Minus 2D and 2D, minus D and D. And I start adding them, yes? So you see how many terms are left? T1, 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 5 of them. Yes, Tn, 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 and Tn, 5 of them. Yes, is equal, if I add these together, it becomes how much? 270. Yes? And I divide everything by 5, so it becomes T1 plus Tn is 40. And what is that? What? 70 divided by 5 is 14, yes? So this becomes 54. Yes. Yes, agree? So I have this one. But now let us look at the formula for Sn, because I know that the sum of the first to the last term is n over 2 T1 plus Tn. This formula, we have it on the board, but I also know the sum of all the terms is 351. So this means that this is 351. Agree? But then you see that immediately I don't need to know T1, I don't need to know Tn individually, but I need to know the combination. And I know that this is 54, so I put it here and I find my n. So it is a much easier way to do that. You see, the algebra was not complicated. Okay? So what happens here, instead of T1 plus Tn, I put 54. So this becomes n over 2 times 54. So I'm replacing it here. It's equal to 351. So then what happens? This becomes 27n is equal to 351. So if we haven't done anything wrong, this should be a natural number after division. Yes, is it? Yeah, it is 13 times, yes? So n becomes 13. So the number of terms which was missing, we calculated that. You see, the algebra is much simpler. The reason that it takes a little bit longer because I want to explain it for you, but just imagine it and adding them together, immediately you get n equals to 13. Okay. So, if you go back, we had this equation, and now we know that n is equal to 13. So if I go back and put it there, it becomes t1 plus 10d is 43. You see, the hard part of this first way of solving is not these equations, or solving the last equation. So that would be one of them. Do you remember I had something on the board that I cleaned? What was that? Do you remember? It was t1 plus 2d, I think, yes? Was it?
I have a question.
Yes?
Why do you calculate n when you can do it much simpler? Because you can put n as 5, right? And then you will calculate the sum of 55.
Here,
Yes.
if I did it in that way, then that was the way that I did it first. Then the problem is that this method, I don't know, I just want to show you that this method is simpler. If I want to write as 5, then how should I use this? That was the way that I did it first. And that is not wrong. It gave rise to these three equations.
Yeah, no, I mean like, now you have t1 plus tn is equal to 54, right?
Yes?
And you, instead of using the sum for all of the terms, you can use the sum for 5 terms. And then you calculate t1 from those two equations. And then you just put that t1 in the first row.
Oh, I'm doing it.
Yes, I know, but it's much easier.
No, it's not easier. So if you say, so what you are saying, you say that I write as 5?
No. What I'm saying is that now you have the sum of 55 there, right? You put your arrow to
Here.
No.
Here.
No, the other one, like the arrow.
Yeah.
Yeah, this one. You said that's the sum of all of the terms, right?
Yes.
But I'm saying instead of using sum of all of the terms, why don't you just put sum of the first 5 terms?
No, if then it becomes 5. It becomes 5 over 2,
Yes.
t1 plus t5. I don't know t1 plus t5. I know the first one plus the last one. Yes, that's the reason. Okay, but I don't want to repeat that. So do you remember what I wrote here, t1 plus 2d? Do you have it in your notebook or not? So we should do it together again. So if I add these first 5 terms, so it becomes 5t1, and then 1d, 2d's, 3d's, yes, and then 4d's. So what happens? It becomes 7, 9, 10. Is equal to 55. So okay, t1 plus 2d, but it was 11. Yes? So and then this is a really simple equation to solve, system of equations. So if I subtract them, it becomes 8d is 32, then it means that d is equal to 4. And then when I put this here, t1 becomes 3. Yes? So you see that this is a much simpler way to do it if you have interpretation, not using the formulas blindly. So you see that I use the formula here. I also use the formula when I wanted to add these. But then I also had some other, I don't know, smarter way to do these things instead of solving that system. In principle, if I solve this system, I solve this equation, I should be able to get it equals to 4. Yes? Okay. But if I want to solve this, so what I do, I use the sum of these terms using this formula. I get to this equation. After dividing by 5, I get this equation. And this way of doing things, I will get n. Yes? And then when I have n equals to 13, I put it in the first equation that I got it from the previous method for 250, yes? And then I can solve the system simply. So this example is a good example because usually the problems in this is very simple. You write the formulas and try to plug in the numbers in, and then yet you get the answers. Of course, that is also one part of this course, so you need to know also those methods. But sometimes it becomes harder. You need to think deeper, okay, if you want to solve the problems. Okay. For example, let me also give you another type of these examples. I want to see how do you think about this problem. Okay. Any questions here? Understandable? So you have to do the algebra once more to understand. But the key point was trying to write this. So if you write it in that way, when you add these that you have written with positive sign and these that you have written with negative signs match together and they cancel out. And then you can solve the problem easier. Okay, let me give you another problem of this type. Okay. This is like an identity. So in any arithmetic progression, I want to prove this formula. So, example. In any arithmetic progression with n terms and the common difference d, show that. So this is written as Sn, the sum of the first n terms, minus 2 times S sub n minus 1, and then plus Sn minus 2 is equal to the common difference. Of course, for this formula to make sense, the number of terms should be at least 3. Okay, so I would write here n is greater than or equal to 3. Okay, if you want, I can write the formula here once more. So the formulas for Sn that we had was these two formulas, yes? T1 plus Tn divided by 2, or you can write it as n times 2T1 plus n minus 1 d divided by 2. Yes, and then if you want, I can write this one as well. So T1 plus n minus 1 d. So these are the formulas that I'm not saying that you have to use them, but if you need any formula in the formula sheet, these are the only ones given in the formula sheet related to the arithmetic progression. So this tells you that if I add the first n terms minus 2 Sn minus terms, minus 1 terms, and then plus Sn minus 2 terms, it becomes exactly the common difference of that arithmetic progression. When I look at the solution in this book, they have chosen the very long method to solve the problem. It's not wrong, but so let me pause the video and give you a little bit of time. Okay, at least any idea how to do this? So here I want to start from the left-hand side, apparently, and I want to reach to the right-hand side, yes? So do you have any idea? What should I do? So for Sn, we have the formula exactly in front of you. And if you want to write S sub n minus 1, then what you're supposed to do, you have to replace n with n minus 1 everywhere, yes? And the same thing for S sub n minus 2. Is that clear? So when I say that S sub n is, this formula is preferable here because it involves d, and on the right hand side I have something related to d. So if I want to choose between these two formulas, I will definitely use that one because it is related to d somehow. Of course, it is also related to T1 and it is also related to D. Sorry, to N, but you don't have any T1 and N there, but let us just do something at least. So what I'm trying to say is that instead of Sn, I can just write the formula. So it becomes N times 2T1 plus N minus 1D, okay, divided by 2. This is Sn. But then I have minus 2 times. Instead of Sn minus 1, I want you to understand that I can do something like that. Instead of n, I put n minus 1. And then I will have 2t1 plus. Instead of n, I put n minus 1. There is a minus sign here. So it becomes minus 1 here. It becomes n minus 2. And then d. And then you divide it by 2. And finally, for s sub n minus 2, you do the same thing. So it becomes how much? It becomes n minus 2, 2t1 plus n minus 3d divided by 2. So first tell me, is that understandable what I have written here? I have replaced those expressions with the corresponding formula. The only thing that I want you to learn is that if Sn is this, S sub n minus 1, it means that replace n with n minus 1 everywhere. Replace n with n minus 2 everywhere. And then I have to simplify this expression. Yes? The good point is that the denominator of all of them is 2. So what I do is this. I would write, if you don't mind, let me factor a 1 over 2 from here, 1 over 2 from there and there to simplify things. And then, so this 2 is here. What I need is to multiply n inside. So what happens, it becomes 2nt1 plus, I multiply n inside, and then let me multiply everything. So it becomes n squared d minus nd. Yes? So I multiply n here, and then n times this is n squared minus n, then I multiply d. Okay, so here, 1 over 2 I have already taken care of, but there is a 2 left here with negative sign, so be careful about that. So you have to, I don't know, we can do it step by step. This 2 is multiplied here, then I have to multiply it inside. So let me write it. It becomes minus 4t1, yes? Let me do it step by step, okay? Is this one, and then I will multiply this inside, so it becomes minus 2. So please watch my calculations, yes? If I am doing something wrong, please immediately let me know. So, do you agree with me? So I multiply minus 2 here, and then take minus 2 and minus 1 and multiply it here, multiply it there. It becomes this. Yes? Is that right? And I will do the same thing for the next one, but I have already taken care of this 2 in the denominator here by factoring it out. So what is left for me is to multiply this with negative sign, yes? So it becomes minus 2 n minus 1, n minus 2 t1, and then minus n minus 2 n minus 3 d. This one? No, this minus sign goes for this and that. In this one. Okay, thank you very much. So that one is, thank you very much. Yes. Now that was plus. Okay, then I don't know. This is a simple Math 1C problem. So you want to expand that, yes? It's just expanding these expressions, but for Math 1C it might be a little bit complicated, but for you it should be very easy, yes? So what I will do it like this. So it becomes 1 over 2. Let us expand everything. This is already expanded, so I don't need to be worried. 2nt1, and then I will have n squared d, and then I will have minus nd. Yes? Okay. Here I have to multiply this in, so it becomes minus 4t1n, but positive 4t1. So minus 4t1n, positive 4t1. Again, please watch my calculations. So here, I have to multiply all these things. So let me multiply these to n times n squared. It becomes n squared. Minus 2n minus n is minus 3n. This becomes positive 2. Yes? And then I multiply it by minus 2d. So it becomes minus 2d n squared. And the next one is positive 6nd. And the last one is minus 4d. Agree with me or not? And then we go to the next term. I have to multiply this. This is easy. So it becomes 2nt1. 2nt1. And the next one is minus 4t1. And then here again, let us do it in our head. N times nn squared times d in n squared d. This times that is minus 3n. This times that is minus 2n minus 5n times d minus 5nd. And then minus 2 times minus 3, positive 6 times d, positive 6d. Hopefully we haven't done something wrong. This is done. If I have done everything wrong, everything right, then what happens is that you need to actually simplify, and it should be d. Let us hope for the best, yes? So here, 2nt1, this one, and that one are gone. Yes? So this one and this one becomes minus 2t1n, positive 2t1n are gone. What more? So minus nd, positive 6nd is positive 5nd, minus 5nd are gone. And then what about this t? Okay, that's good. This 4t1 and minus 4t1 are gone. And then what is left for me?
6
So
minus 14 plus 16.
is 2d, yes? This is not gone, so let me just write it. So it becomes 1 over 2. This one, as you told me, with this one is 2d.
Yes.
And then hopefully everything is gone, yes?
Yeah,
Except
Yeah, that one
it's gone.
and that one is 2, but there is a minus 2 there. Yes? And
Oh,
then
yes.
this 1 over 2 times 2 is
D.
d, and that is equal to the right answer.
Oh.
Yes. So it was right. But this is not a good way. I don't know. This book is also using this method. There is a much easier and simple way to do this. Can you imagine about that method? So this is, if you write this in the exam, if I will give you the full mark with this method, but you see it is very lengthy. So I just want to tell you that before solving these problems, try to think a little bit deeper, and then if there is no way that you can just do it simpler, just use the formulas. There's a much better way to do that. Is there any idea? Okay, let me write it in this way for you, and then you tell me why this is useful. So if I want to solve this problem myself, I would start from the left-hand side again, but instead of plugging the formulas directly in, I would write it in this way. First of all, tell me, is that a valid way of writing the left-hand side? Yes, because I have broken this into 2 parts, decomposed it into 2 parts, yes? But then, what can I do?
Yeah, that's a good question.
No formulas needed.
No, okay.
No problem is needed.
So what is the meaning of this?
It's
Sn,
It's just with the head.
it's the nth term.
yes.
Yes, because this means the sum from the first up until the nth term. This means the sum from the first term up to Tn minus. So let me write. What is the meaning of Sn? Sn means T1 plus T2 up to Tn. Agree? But the previous term is Tn minus 1. The Sn is the sum from here to here. What is this called? This is Sn minus 1. So if Sn minus 1 is just Tn. Right?
Yes.
So instead of this expression, I can write Tn. Okay? And instead of this expression, let me factor a minus sign out. Okay, can you tell me what can I write instead of? So minus sign, what can I write here? What is s sub n minus 1 minus s sub n minus 2?
It's Tn minus 1.
Tn minus 1, yes, for the same reason. Yes? And what is Tn minus 1? In an arithmetic progression.
Tn?
No,
Wait, no.
Tn
Ah.
minus Tn minus 1. Any term minus its previous term in an arithmetic progression.
Then D.
It's D, finished, yes? So that problem becomes D, yes? And this is the right answer.
I told you.
So I don't know why the book has chosen this method. This is much simpler, yes? Is that understandable? So what I'm telling you is that before plugging the formulas in, try to understand what is going on. So you see that it was possible to do using algebra, and it was done, and it was actually good, but this is much faster and easier. I want you to understand, do you understand what is going on?
Yes.
So I broke this middle term into two terms, and then I pairwise take them together, and then what happens, this one becomes Tn, for the same reason this becomes Tn minus 1, and this is the difference between two consecutive terms in an arithmetic progression with the common difference D, so the answer would be D, as simple as that. Okay, and let me give you another example, which is a little bit related to number theory as well. I'm not saying that this method is not always possible, but before starting doing the heavy algebra, think about an alternative method if possible. Otherwise, you have to use sometimes the algebra. Okay, there is a good problem here I see. Let me just write this one for you as well. And the problem is that determine the sum of all three-digit natural numbers whose remainder whose remainders by 11 are 7. Okay, so it means that you have three-digit natural numbers starting from 100 up to 999. So this is the range of the numbers we are interested in. I'm not interested in all of them. I am interested in only that part, so that when I divide those numbers by 11, the remainder is 7. I want to have those numbers and I want to sum them up. And I want to find the final sum. Is that clear? So, for example, what is the first number in your list? So if I just write three-digit numbers, the three-digit numbers starts from 100, 101, and it continues 999. Okay? But I am not interested in all of them. I am interested in those of them, so that when I divide them by 11, the remainder becomes 7. So what is the first number with that property in your list? Yes? 117. I don't know, how did you get that?
Oh, that was...
So do you know by number theory that the numbers are of this form, yes?
yeah.
The numbers should be of this form. We learned it in number theory, division algorithm, yes? A number which I divide by 11 and its remainder is 7 is a number of this type. So and then you know that q is an integer, so you need to find the smallest q which gives this number into this range, yes? So it means that you want to have this one greater than or equal to 100. And then you move it here, so it becomes 11q greater than or equal to how much? 93, and then you divide by 11. It becomes 93 divided by 11. This is approximately 8 point something. Q should be an integer larger than 8 point something. So the minimum Q is what? Is 9. And then you put it back here. So the answer would be 106. Yes, you said that 100? No, I think the answer is 100. So you see that, what is that understandable? Let me repeat this. The numbers that you divide by 11 gives you the remainder 7 according to what we learned in number theory are of this type. Yes? Where Q is an integer. But I want to have my number in this list. So I want to have this number greater than or equal to 100. I moved 7 to the other side and I divide by 11. 93 divided by 11 is 8 something. It doesn't reach to 9. It's 8 something. Q should be larger than this 8 point something, and it should also be an integer. So the minimum value that you can get is 9. You put 9 back into this equation. 11 times 9 is 99, plus 7 is 106. So then the first number in your list is 106. I will pause the video and wait for you. I think you know what to do from now on. Okay, what happened? What is the last number in your list? 997, yes? It's clear. The last number in your list is 997. Why is that? Because 990, of course 990 is 11 times 99. Am I right?
Yes.
Yes? And then of course, and then you get 7. So it means that 900, if I add 7 to it, then I will have this one. So the last one is this. If you want, of course, you can calculate it using this method. Let me just use this method. You would say that this time, I'm interested in finding that number which is less than or equal to 999. I move that to the other side. It becomes 992, and I divide by 11. So this becomes approximately 90.1, etc., etc. But this time you are interested in Q max. The maximum value for Q is how much? 90. Because it should be an integer and it should be smaller than that number, so Q max is this one. So if you put back here, you get exactly 997. But the point is that what is coming after 106? What is that number? So because I know the first one, I know the last one, but I need to know if I want to, this is related to this arithmetic progression lesson, I should have this as an arithmetic progression, otherwise I will not be able to use the formulas. It becomes a sequence, of course, but if that is not an arithmetic progression, I'm not able to use the formulas. But is it an arithmetic progression or not? What is the next one? What? 117, yes. So this becomes, the next one is 117. Why is that? Because the number that I have 11Q plus 7, if I ask you what is the next in this list, it means that I have to increase the quotient by 1 unit. Yes? And then if you see what happens, this becomes 11Q plus 7, but plus another 11 coming here. So it means that when I go from one number to the next number with that property, I have to add 11 to it. So it means that the common difference is 11. So indeed, it is an arithmetic progression. The common difference is 11. So, okay. But the point is that if I want to add them up, I will be able to use the Sn formula, but in Sn formula I need to know n. That's the problem, yes? So what I should do, I would write that I have this arithmetic progression, 106, the next one is 107, and then it continues to 997. And I want to find Sn. Okay, so Sn becomes n times the first term plus the last term divided by 2. The point is that I know the first term. I know the last term, but I need to find n as well. So what is n? How should I find n? In general, might be it is not hard to guess here, but in general, if you want to find n, you have to use this formula. The last term is equal to the first term plus n minus 1 d. The last term I know is 997. The first term I know is 106. N I don't know, but d I know is 11. And then I have to solve this and find n. So be careful about this. Sometimes you have the common difference, you have the first term, you have the last term, but this is a very long list that it is not possible to guess, or I don't know if you want to do it manually, it would be time consuming, but this is the idea. You write the last term for Tn, you write the first term, and then you put d here, and then that's the only unknown left. So I move this one to the other side, it becomes 198 is equal to n minus 1, 11. I divide by 11. So this becomes how much? 81, yes? And then n becomes 82. Yes. So n becomes 82. So I know that n is 82. I put it back and I get my answer. Yes. So Sn, in principle here, 82 terms. It becomes 82. T1 is 106 plus 997 divided by 2. So then if I simplify with that, it becomes 41. If I add them, it becomes 3. Yes. And then 0. And then 11. Yes. And then you multiply these two. Whatever this number you get is the answer. So that's also a good problem, you see. The problems, otherwise you can get them in the book. There are some good problems in the book as well, by the way. Any questions here? Is that understandable? Is the question clear? So I have three numbers A, B, and C. When I square A, when I square B, when I square C, it becomes three numbers. When I look at these three numbers in this order, I recognize that they are consecutive terms of an arithmetic progression. Now, I take these three numbers, instead of making this combination, I will make these combinations, yes? These are three numbers again. I want to claim that if they are consecutive terms of an arithmetic progression, these three terms are also consecutive terms of some arithmetic progression, not necessarily the previous one. Okay, I will leave this example for you for the next time, but I just want to ask you, how do you think you can use this piece of information? When you say that I have three numbers, let us call them A, B, and C. If you say that these three numbers are consecutive terms of some arithmetic progression, what does that mean? Because if you understand what is the meaning of this sentence, you can translate these two sentences in mathematical terms, and of course you know what to do. But what is the meaning? If you have three numbers, how do you realize that actually they are the consecutive terms of an arithmetic progression? Yes?
A plus C minus B.
So simpler than that, yes. That's so you have. Do you have any? Okay.
A plus a common difference.
Yes, but we don't have D here. So can you exactly? But can you write something? Because when you say D, it means that you are bringing a parameter into the problem which is not in the problem itself. So I want you to write something in terms of A, B, and C only. But what you said is correct. What you also said is correct. So what does it mean? It means B minus A is C minus B. Yes? As simple as that. So because B minus A is the common difference, whatever it is, C minus B is also the common difference. If this happens, then I am done. Of course, I can simplify this a little bit. I can move it to the right hand side, it becomes 2b, and then I move it here, it becomes a plus c. This is very good to know. Three numbers are consecutive terms of an arithmetic progression if 2 times the middle one is the sum of these two. If this happens, yes? So this is the crucial point that you can use that to solve this problem easily. If these problems are consecutive terms of an arithmetic progression, it means that 2 times the middle one is a squared plus c squared. Then you want to show that the same happens for these three numbers. 2 times the middle one is the sum of these two numbers. So that becomes a simple algebra. But remember this one, please, yes? If three numbers are consecutive terms of an arithmetic progression, if and only if 2 times the middle one is the sum of these two numbers on the left and the right. Okay, the next time we will solve this problem and immediately go to the next topic, which is geometric progression. And then, by the way, we have to come up with a date for another exam on this chapter, okay? So this is week 47 now,
Yes.
and the last week of school is 51.
Yes.
I think 51 is the best choice for us.
What?
Yes?
Yes.
Week 51, yes? Is that okay? Okay, let us not decide today, because mathematical induction is also important. So after that we also need to teach. Let us think a bit. We can come up with that later. Thank you very much.